So the third category that we're looking into today are algorithmic stablecoins. So if you look at our taxonomy here, you can see algorithmic stablecoins are anywhere between endogenous to no collateral to having both exogenous and endogenous collateral. So let's look at the specific samples in particular. So what's interesting is that all algorithmic stablecoins that we are looking at adjust the supply, right? And this is quite a systemic change, because if you adjust the supply, then all the AMM pools, automated market maker pools, the DEX pools, the lending pools are somewhat affected because the supply changes. And this opens up, for example, arbitrage opportunities. What we're seeing here, there are different token models or different different algorithmic token models that we're seeing. So, for example, Ampleforth here is a single token model. There's partially collateralized. There are partially collateralized algorithmic stablecoins such as FRAX. There are self-baked stablecoins such as UST, and we'll briefly discuss its crash in a later slide. And there are coupon or bond-based models such Basis Cash that have also not succeeded, unfortunately. So let's look at the difference between a single and a multi-token algorithmic stablecoin model. So what's interesting is here, once we go beyond the multi-token model, we somehow want to have an economic incentive for stability. Right? So in a multi-token model, users are essentially incentivized to keep the stablecoin at $1 through economic incentives and punishments. And these are typically through arbitrage. So there's some kind of incentive to go either to mint or to redeem or to burn tokens, depending on the current market prices. And you may ask, well, why is DAI not an algorithmic stablecoin? Well, it's because we have a collateralization ratio that's beyond 100%, right? We are at 150% collateral. So that's why it is typically not categorized as an algorithmic stablecoin. So let's look at the first example, Ampleforth, which we briefly discussed in the introduction. So that's a token, that's a stablecoin with no collateral. And the way it works is that we have the Ampleforth smart contract, this one here, and it receives a price reported by a price oracle. And this is the USD price compared to the Ample token price. And there are three states. So if the one Ample token is worth more than $1, we want to lower the value of the Ample token. And therefore, we add a supply. So there's an expansion in the supply. If the Ample token is worth less than $1, we want to increase the scarcity of the protocol, so we're gonna remove the supply. And if there's no change, so if one Ample is equivalent to $1, then there's no action taken. And as I mentioned earlier, so having such an expansion and contraction implies systemic events, such as the occurrence of arbitrage opportunities, etc., that can happen at when a token becomes suddenly worth more, or if the supply changes. So FRAX is another stablecoin and has a stability mechanism by which you collateralize USDC and FXS. So here we need to determine a certain ratio of how much is being collateralized, and this depends on the so-called collateralization ratio here. And you might ask, okay, why do we need this oracle, right? This initial oracle here. And that's because we need to determine the exchange rate to USDC, right? And once you collateralize USDC and FXS in the set collateralization ratio, you receive in return this FRAX token, which is supposed to be a stablecoin. Now, you can also redeem FRAX again against USDC and FXS. So if FRAX is worth more than $1, you have an incentive to mint, and if FRAX is worth less than $1, you have an incentive to redeem this particular token. So the collateralization ratio here in this algorithmic stablecoin is adjusted by, in the beginning there was a rebase every hour, and now currently it's adjusted, as far as I know, manually to depending on the protocol's growth. This collateralization ratio also, in essence, is a proxy to measure the liability of this protocol, right? So the less USDC you have, the more risky that might become, because it depends more on the FXS value, and vice versa. Another quite infamous algorithmic stablecoin is the UST. UST has no collateral at all, and there was a big question mark whether this would yield full stability. So the expansion requires Luna to be collateralized, and it allows you to mint Terra. The contraction is the reverse, right? So you give back Terra to the smart contract and you receive Luna. And if the stablecoin is worth more than $1, then you have an incentive to burn Luna and mint Terra. And if the stablecoin is worth less than $1, you have an incentive to mint Luna and burn Terra. So there's really no collateral at all here, which means that the value of Luna fully depends on its adoption. And therefore, if the value of Luna declines significantly, this will definitely, and it has, as we have seen, it will negatively impact the stability of the stablecoin. As most of you know, UST resulted in a collapse. I will not give you a full breakdown of how the collapse happened, and this has been discussed really extensively and very in detail in related works as well as blogs, etc. And what I will do is I will point you to here the Chainalysis blog that literally dissects for you which trades triggered this collapse of the UST algorithmic stablecoin. So I can really recommend you to check this out, and feel free to also discuss in our Discord the different events that led to the collapse of UST. So now if we compare the different algorithmic stablecoins, obviously we know that the Terra UST collapsed to nearly zero. We have FRAX here on the left side. Please mind the scale on the y-axis, right? And we have Ampleforth here on the right side. And you can see that Ampleforth had quite some volatility, but so far it has not depegged permanently. It always managed to somewhat come back to its initial to its goal, so to speak. But it seems like the best model for stability overall is to have a partially collateralized stablecoin. And we also can see that the higher adoption, the higher the adoption of Luna became, the higher its stability became. So sometimes stability is somewhat, you could say, not a good indicator of whether something really is fundamentally stable in the long run against adversarial trading, etc. So it's not fully clear here how to best quantify long-term stability, but it's a very exciting experiment that the community is engaging in. So I hope this lecture on algorithmic stablecoins sparked your interest to go deeper and hunt the details of how UST collapsed. It certainly is a very interesting story.